Good morning, students. Today I am going to explain about bearing capacity of soil. This is the topic included in shallow foundations bearing capacity criteria. First of all, everyone should have clear knowledge. That means a civil engineer should have clear knowledge about bearing capacity of soil, because before construction of any structure, it is mandatory to calculate the bearing capacity of that particular soil. If the soil has sufficient bearing capacity, then only one should design and construct a building on that soil. Without proper bearing capacity or sufficient strength, if we construct building on that soil, then it is going to fail. So bearing capacity of soil plays a very important role in the construction of any type of structure. Today's class I am going to explain about bearing capacity of soil clearly. So first of all, definition of bearing capacity is bearing capacity means the ability of a soil to support the loads applied to it from a structure. So this is the basic definition of bearing capacity of soil. Once again I am repeating, the ability of soil to support the loads applied to it from a structure. So already we know that the structure what we construct above the soil is called as superstructure, and the structure below the soil is called as substructure. So the soil plays a very important role. The soil plays very important role in the construction. So the main purpose of knowing the bearing capacity of soil is whether it has sufficient strength or whether the soil has ability to support the loads that is coming from the superstructure. So that is what included in this definition. Bearing capacity refers to the ability of soil to support the loads applied to it from a structure. That structure is nothing but superstructure. So whether the soil is capable of supporting the loads coming from the superstructure or not. And one more definition of bearing capacity is it is the maximum pressure that soil can bear without undergoing shear failure or excessive settlement. So this is the other definition for bearing capacity. The maximum pressure that soil can bear without undergoing any shear failure or any excessive settlement, up to which pressure the soil can bear that load, that can be considered as bearing capacity. So after learning the definition of bearing capacity, types of bearing capacity is the next thing. So three different types of bearing capacity are there: ultimate bearing capacity, safe bearing capacity, allowable bearing capacity. So first one is ultimate bearing capacity. Already we had seen bearing capacity definition. Now this is ultimate bearing capacity. The maximum pressure a soil can withstand before failure occurs. Till the edge of failure, what is the pressure the soil can bear? That means above that a small milligram of pressure also leads to failure. So the maximum pressure a soil can withstand before failure occurs. Just before failure occurs, what is the maximum pressure that soil is going to withstand? That is considered as ultimate bearing capacity. Next thing is safe bearing capacity. The maximum pressure a soil can withstand with a factor of safety applied. So after applying the factor of safety, how much pressure a soil can apply? That can be considered as safe bearing capacity. Next thing is allowable bearing capacity. The maximum pressure allowed to ensure long-term stability without excessive settlement. So this is considered as allowable bearing capacity. The maximum pressure allowed to ensure long-term stability. In order to maintain long-term stability and in order to overcome this excessive settlement, what is the maximum pressure that is allowed? That is called as allowable bearing capacity. So coming to the factors affecting bearing capacity, because this bearing capacity plays a very important role in the construction, we should be very careful about the factors that affect the bearing capacity. Several factors influence soil bearing capacity. Uh, the soil bearing capacity in turn affects structural stability. All these are related. Structural stability is related to soil bearing capacity, and the soil bearing capacity is influenced by certain factors. Let us see the factors one by one. Soil type and composition is the first factor that affect bearing capacity of soil. There are different types of soils. We already know that: sand, clay, silt. So soil types, different soils have different strength factors and also different load bearing capacity factors. So based on the soil type and based on the composition present in that soil, the soil strength and also load bearing capacity is going to affect. That's why the first thing that affect the bearing capacity is soil type and composition. Next, moisture content influence. As apart from the soil type and composition, the next thing that is influencing the bearing capacity is moisture content. We already know that moisture content means water content present in the soil. This moisture content can weaken or strengthen the soil. That also in turn affects the load distribution. So moisture content means the water content present in the soil. It has the capacity both to weaken and also strengthen the soil. Excessive amount of water content weakens the soil, and required amount of water content strengthen the soils. So these both in turn affect the load distribution. So the next thing affects the bearing capacity is moisture content. Yes. Depth of the foundation is one more factor that affect the bearing capacity. As the foundation is deeper, that can improve soil strength and also support heavier loads. So that means a deeper foundation can often improve soil strength and support heavier loads. Load distribution effects. So uniform or concentrated loads. So various loads we are having: uniform loads, concentrated loads, that is UDL, uniformly distributed loads, concentrated loads, point loads. These impacts how the soil distribute the stresses. Yes, these are the various factors. Once again, I am repeating the various factors that affect the bearing capacity. So bearing capacity is a very important criteria that is related to structural stability, and this bearing capacity is affected by certain factors such as soil type and composition, moisture content, depth of foundation, and load distribution effects. All these are the very important factors that affects the bearing capacity. Now let us know about various methods for determining bearing capacity. So this bearing capacity is a very important thing, and the calculation is not that much easy. So there are various methods for determining bearing capacity. So in order to maintain it for practical applications, so first method is Terzaghis bearing capacity theory. So Terzaghi did a great role in determining the bearing capacity formulas, and he created one bearing capacity theory. So that is called as Terzaghi's bearing capacity theory. So this theory provides fundamental equations for calculating bearing capacity. So the equation, bearing capacity equation given by Terzaghi is shown in this slide. We can clearly see that Qu is equal to CNC plus gamma DFNQ plus 0.5 gamma BN gamma. So this is the formula or the equation given by Terzaghi for calculation of bearing capacity. Their Qu shows ultimate bearing capacity. So after continuous research and work done by Terzaghi, he gave one final equation for bearing capacity calculations. That is Qu is equal to CNC plus gamma DFNQ plus 0.5 gamma BN gamma. So in this the terms Qu means ultimate bearing capacity of the soil, C means cohesion, Nc, Nq, N gamma are the bearing capacity factors, and gamma is unit weight of soil as usual, Df means depth of foundation, and B is width of foundation. So Qu means ultimate bearing capacity, Nc, Nq, N gamma plays a very important role in this equation, and those are bearing capacity factors. And based on the pi value, that means pi angle of shearing resistance pi value, these values vary. So C is cohesion, gamma is unit weight, dF is depth of foundation, and B is width of foundation. That is about Terzaghis bearing capacity equation. Next, by conducting the standard penetration test, bearing capacity can also be estimated. So, this standard penetration test is called as SPT, and this is the field test that measures soil resistant to penetration for bearing capacity estimation. First of all, this test is conducted in the field, and this measures soil resistant to penetration. Whenever some sampler is penetrated into the soil, how much resistance that is getting offered by the soil, and from that resistance bearing capacity is estimated. So the standard penetration test includes a standard split spoon sampler. That standard split spoon sampler is inserted into the soil, and by using hammer, 65 kgs hammer, number of blows are given on that split spoon sampler to insert that sampler into the soil. So number of blows are recorded. So first 150 mm penetration is done. So the number of blows required for the sampler to penetrate into the soil for 150 mm. So number of blows for that is calculated, and next 150 mm for penetration of next 150 mm, how many number of blows are required, and next for penetration of one more 150 mm, how many number of blows are required. So the standard penetration is conducted in the field in this way. A standard split spoon sampler is taken, and that is slowly inserted into the soil by using a 65 kgs hammer, drop hammer, and with the drop hammer number of blows are given, and the number of blows required for 150 mm penetration is calculated, and the second 150 mm is also noted, and third 150 mm is also noted. The number of blows required for first 150 mm is disregarded, that is taken as seating drive, and the number of blows required for next two 150 mm are considered as standard penetration resistance, capital N, and by using that N value, bearing capacity is calculated. This is the simple field test conducted to calculate bearing capacity. And one more test is plate load test. This is a direct method where the load is applied to the plate on the soil surface to determine the strength. So direct method, by using this method, load is applied on the plate on the soil surface, and the strength, how much strength it can resist, is determined. So that is about plate load test. All these what I am explaining now is regarding the methods to calculate bearing capacity. First one is Terzaghis bearing capacity equation. By using that equation we can calculate the load bearing capacity, and second one is standard penetration test, SPT, and this one is plate load test. All these methods are used for calculation of bearing capacity of soil. And one more test is cone penetration test. This is called as CPT. In this we are having dynamic cone penetration and static cone penetration test. So soil penetration test, soil penetration resistance using a cone is measured in this cone penetration test, and this is used to estimate bearing capacity. A test that measures soil penetration resistance using a cone to estimate bearing capacity. That is about cone penetration test. And different other empirical methods are also there. Based on empirical relationships and based on past data, soil bearing capacity can also be estimated. So that is about bearing capacity definition and various types of bearing capacity, like ultimate bearing capacity, safe bearing capacity, net bearing capacity, and later we have discussed about various methods for calculation of bearing capacity. The methods include Terzaghis bearing capacity equation, standard penetration test, plate load test, and this one is empirical methods. So by using all these methods we can calculate the bearing capacity of the soil, and also we can estimate what is the safe bearing capacity of the soil, and finally after getting the bearing capacity of the soil, based on that bearing capacity, we can design the structure as well as we can start constructing the structure without any doubts. So bearing capacity plays a very important role for design and construction of buildings. So if the soil is having low bearing capacity, we need to apply only low loads. If the soil is having very high bearing capacity, then we can proceed with greater loads. In some cases, if the soil is having low bearing capacity, then we can improve the bearing capacity by using ground improvement techniques. Thank you.